Welcome to the Natural Health Podcast, where we explore the depths of holistic health, uncovering the interconnectedness of our emotions, mind, body, and spirit. This podcast is dedicated to individuals who are on a quest to uncover their truth, understanding their genetic and spiritual DNA, and learning how to harness this knowledge to achieve optimal health. But this isn't just another health podcast. Natural Health Podcast is here to ignite a spark of hope within you, reminding you of your inner potential for greatness. You are pure love, capable of living life to its fullest expression. Are you ready to embark on a transformational journey to achieve optimal health? Welcome to the Natural Health Podcast. Today, the next few podcasts, solo ones, we're doing things different. We've done the medical astrology, a whole year of medical astrology in sense. We've gone through all the zodiac signs and I've spoken about potential health implications of those zodiac signs. If you're a sun, moon, rising, or if you have a stellium or any of those signs more in your chart than usual, right? If they're prevalent in your chart. So if you want to know anything about medical astrology, jump onto the last 12 or so or 24 or so podcasts before this one. Now we're moving into the DNA part, the genetic DNA part, where I'm going to be talking about specific genes. So if you are interested in doing a DNA test, or you've done a DNA test on yourself, which is amazing. So if you've done a DNA test, this is going to be so helpful for you because we're going to go through a few things. But you know what? Even if you haven't done a DNA test, you might be like, oh my gosh, that sounds like me. I potentially may have a SNP, a SNP on that DNA or on that gene. I might have something there that is reducing the enzyme production. So let's get into it. I'm going to start off with a gene that, look, a lot of people don't really talk about, but I think it's absolutely vital. And excuse me, but I will not be able to pronounce the whole name for it. I will try and you can laugh. All right, well, today we're going to be diving deep into the PEMT gene, a gene that plays a crucial role in fat metabolism, liver function, but also overall cellular health. So what does PEMT stand for? Are you ready to have a laugh? All right, I'm going to try and break it down. Phosphatidylnoamine N-methyltransferase. Fun, right? So we're just going to call it PEMT for now. So what is this enzyme responsible for? This is an enzyme. An enzyme needs cofactors to work. But besides the cofactors, you can make an enzyme go faster or slower, or you can be born with an enzyme genetically that's faster or slower. Okay, so this enzyme, the PEMT, helps the body convert, are we ready to have another laugh again? Phosphatidylnoamines, PE, which I'm going to be calling, into phosphatidylcholine, which is PC, an essential fat for cell membrane, liver function, and lipid metabolism. So as you can see, this has a lot to do with liver health, but also fat metabolism, lipid metabolism, and how fat is stored and what's done with fat, okay? So the key functions of PEMT gene, the enzyme, is liver fat metabolism and prevention of fatty liver. Oh my gosh, like who doesn't have fatty liver? You know someone that has fatty liver. So this gene is so important. The production of choline and phosphatidylcholine, critical for cell membrane, which is the PC that we spoke about, supports lipid transport, detoxification, and methylation. Yes, I'm going to get into the methylation on that gene on another little podcast. I'm going to talk about the MTHFR gene and its other genes like the MTR and so forth. But this is really important. The PEMT gene is important in that methylation cycle. It's also important for brain health and neurotransmitter synthesis. So what does this enzyme not do, right? It's neurotransmitters, it's brain health, it's liver, it's fat, it's cell membrane, so many things. So let's break it down a little bit more so we kind of get a bit of a feel of exactly what it does in our body. So let's talk about the lipid health. Let's go into a bit more detail of that. So with less PC, which is the phosphatidylcholine, which is what the enzyme, remember, this enzyme converts PE into PC, okay? So if we don't have enough PC, there's a potential for some membrane fluidity issues. So what does that mean? We have less efficient nerve signaling. And we know that we need nerve signaling. There's a synapse of one nerve, a synapse of another nerve. It goes doof, doof, grabs it. Doof, doof, grabs it, okay? If you can't see the video version, what I'm saying is the synapse is so important for nerve signaling, and having PC is so important for that to work and function. So if that is not working, we have slower cognitive processing, brain fog. I mean, when was the last time you haven't heard someone say, I have brain fog, I can't think? It may literally be a reduction of this gene, that you may not be producing enough PC, which is absolutely necessary. So therefore, you're not having the best cell signaling. So that's that lipid health, because every single cell has a lipid layer, okay? Choline. Let's talk about choline and acetylcholine. So not having enough PC is so this gene is so important for memory, attention, just having that drive, that acetylcholine drive, which is absolutely necessary. So that's another thing that it does in that neurotransmitter way. The other thing is the methylation and the homocysteine, right? So the PEMT gene uses methyl groups like SAMe, may not make a lot of sense to you, but bear with me, that converts the P to PC. So it needs SAMe. SAMe is a byproduct of methylation. So essentially, if you're not methylating well, you don't make enough SAMe, you don't have enough SAMe, you can't convert P to PC. So do you see how these enzymes, they work like a lock and key and like key grinder and like all these things together? They work in combination together. It's not just one of its own. So without methylation working properly, you're not going to make enough, you're not going to convert the P into PC, right? Which then means you're having a reduced PMT choline pathway, right? So absolutely necessary to have that homocysteine in that level, because if it's not in that level, your methylation is not working well, your PMT is not working well. So you have elevated homocysteine, which means you have fatigue, mood issues, slow recovery. So many things can happen there. Let's talk about the brain. I mean, the brain is so important for all of us. I mean, I want my brain functioning, and sometimes it doesn't. It just goes, ooh, freeze, what's happening? So essentially, combined with a low dopamine tone and histamine overload, reduced PC may limit capacity for attention and energy, slumps, and you may struggle with focus, mental fatigue, just feeling flat. This is what can happen when the PMT gene enzyme isn't working well. And then we're going to the liver and fat metabolism, absolutely key, because I'm going to go into a research study about the PMT gene and also non-alcoholic fatty liver disease. A lot of individuals do have a fatty liver and they're like, I don't drink. Well, it may literally be this gene, a reduction of this enzyme functioning the way it's supposed to. Therefore, you have elevated liver enzyme, you have insulin resistance, just low energy, your blood tests come back, your liver is not working well. It's like, what's the issue here? And the doc goes, oh, how much booze have you had lately? And you're like, I maybe had like one glass this whole year. And they're like, wow, this doesn't make sense because your liver enzymes are through the roof on the blood test. It may literally be a reduction of the PMT gene or methylation or so many other things, but we're just talking about PMT today. The other thing that's really important that we have to understand is bile production. Oh my gosh, like bile production is so key and it's so not spoken about. Bile is absolutely necessary for us to break down the fats, right? Produced by the liver, stored in the gallbladder. And a lot of people get their gallbladders taken out. Why? Why did you get your gallbladder taken out? Why did they say you needed to take your gallbladder out? Yes, in that instance, potentially it was an emergency and it had to be taken out. 100%, I understand that. But what was the build up to it? What symptoms and signs did you have before that? Did you have a fatty liver? Did you have lipid malabsorption? Did you have issues with this gene? Do you have a homozygous PMT gene? Because if you do, there's probably a higher chance that you've got gallbladder issues. Anyway, so yes, so it's absolutely necessary breaking down dietary fats, absorbing fat-soluble vitamins, vitamin A, D, E, K. Your blood test comes back and you're low in vitamin D, and you're always low in vitamin D. You're taking low vitamin D supplements, but you're low in vitamin D. Why? PEMT gene, potentially, right? Also, supporting a healthy gut microbiome by keeping harmful bacteria in check can potentially be a PEMT thing, right? So what happens if you've done a test, or if you're sitting there thinking and being like, Mihaela, I think I have a low functioning PEMT gene. What does that look like? So what that looks like is poor choline production, which then leads to liver fat accumulation, which then means you go to the doctor and they say, congratulations, you have a fatty liver. I mean, they wouldn't say congratulations, but hey, you have a fatty liver. Why? Because you accumulated fat onto your liver, and let's go prior to that, you had poor choline production. Okay, why did you have poor choline production? Potentially have a PEMT gene, or you've just got a dirty PEMT gene. Increased homocysteine can be due to slow PEMT gene, which means you've got methylation issues, you're depressed, you're anxious, you don't know what is happening in your brain. You have impaired lipid metabolism, you have difficulty processing fats and feel fatigued, or your poo is like yellow, green, one of those colors. I forgot which one. I'm pretty sure it's yellow. Yes, it's yellow, and it's like, why is it so light and yellow? Because you're not metabolizing your fats. You're getting pain on the right side underneath your ribs, gallbladder, right? Liver, gallbladder things. You're getting pain in your right shoulder, gallbladder, right? You're not processing your fats. Why? Why aren't you processing your fats? The other thing is also increased risk for pregnancy complications can potentially be due to this also. So what symptoms does that look like in every single day? You're fatigued. You have brain fog. You have a poor memory. You can't concentrate. You have digestive issues. You have issues digesting fats. You have gallbladder issues. You've got pain where the gallbladder is. You've got right shoulder pain that's just coming out of nowhere. You've got difficulty losing weight besides trying everything you've tried. It may literally not be your fault. It may literally be a genetic thing that's been passed on to you. Thanks, mum. Thanks, dad. Been passed down to you, and now you have lipid issues, metabolizing lipid issues. You might be fatigued. Why are you always fatigued? Or have always been your whole life? It may literally be a PEMT issue. Yes, you can have a slow PEMT, and I can just imagine all of you smarties out there being like, Mihaela, what happens when it's fast? Interesting question. Well, you have a higher rapid production of PC, right? You have better fat metabolism and liver support. So therefore, when someone next to you eats a fatty meal, they're asleep, holding their liver, not being able to move on the toilet, and you're like, hey, I'm fine, I'm all good. I eat fat all the time and I'm amazing. So yeah, is that you? And this is where the thing is also a lot of people go keto and a lot of people go carnivore. Someone with a PEMT, should they do that? With a slow PEMT gene? That's questionable. That's really, really questionable. Potentially for a short period of time. For a long period of time, no. Because I've actually seen people's liver enzymes go through the roof while being carnivore, right? And potentially ending up to fatty liver. Potentially they have a PEMT gene, okay? Individuals who it goes really fast for have an increased methylation load and just have better liver support. It's kind of like, is it better? I don't know if I wouldn't say it's better because you're going to be using more SAMe, which means you need to have your methylation on point. So these individuals need to really have their methylation on point to make their PEMT work well. So what diseases and conditions may be linked to this enzyme? Just because if you do have your gene report next to you and you're like, oh my gosh, I have a homozygous PEMT gene, meaning both from mum and dad, potentially a 70% reduction of the gene, does this mean I'm going to get what you're about to talk about? No, it does not mean that. Genes are just part of it. Your lifestyle is a factor. So let's go into what potentially you may be more prone to, okay? Let's talk about it. So clearly non-alcoholic fatty liver disease 100% because of that lipid metabolism. Elevated homocysteine potentially. So if I saw someone have a PEMT gene, I'd be like, can you check your homocysteine on a regular basis? Absolutely necessary to make sure that we reduce the cardiovascular risk that is involved with elevated homocysteine. We don't want homocysteine to be too high, but we also don't want it to be too low. There's a sweet, sweet little spot to have that optimal cardiovascular function. And yes, so the other thing that's also linked to the PMT dysfunction can be neurotube defects in pregnancy. This is where that choline is absolutely necessary. And if individuals have a homozygous PMT gene, I'll be like, hey, eggs or choline supplement or both, right? Depending on their dietary requirements. Fat metabolism disorders, obesity, not being able to lose weight, holding on to fat. This all can be a PMT dysfunction. Potential link to cognitive issues due to insufficient phosphatidylcholine in the brain. So neurotransmitter things happening, moody, fatigue, up and downs, depression, anxiety, you name it, can all be linked to this gene. Essentially, choline moves into acetylcholine, is key for attention, memory. If reduced, the cognitive function may suffer. This is so important for individuals. The older we get, we need to ensure we have enough choline and that PMT gene is working on point and converting that PE to PC, so then we can make acetylcholine and therefore we have enough of it, of as much as we need. So now you're like, all right, Mihaela, well, you told us all the exciting things about the gene. What do I do? That's a great question. Remember, I am a naturopath, but I'm not your naturopath. So anything I say here is literally just for entertainment purposes or educational purposes, whichever one you prefer. Education, entertainment, same, right? Okay. So what do you do if you have a slow PMT? What does that look like? It looks like a homozygous or heterozygous gene on the PMT on your report. So what does that look like? Because PC production is reduced, you essentially kind of have to rely on dietary PC choline to support everything that we just spoke about, to support the liver health, support the neurotransmitters, support lipid metabolism, and so forth. So kind of your diet is your number one medication here. What's your number one medication? Your diet, because your genes need a bit of support, need a bit of, hey, help me out here, especially if you have that homozygous gene. What does that food look like? All right, so I'm going to talk about some foods which a lot of people say do not eat or reduce your intake, or you've heard from your doctor and so forth. So here it is. I'm going to say eggs. Increase your egg intake. And this is if you are not vegan or, if you're not vegan. If you are vegan, I'll go into what you can do later. But if you are not vegan and you eat eggs, increase your eggs. But make sure these eggs come from absolutely amazing little chickens or big chickens, that they are non-antibiotic, they eat amazing, they're outdoors, they're kind of happy, right? You want the eggs coming from happy chickens. So especially the yolk. The yolk is absolutely important. So for all those bodybuilders that are just trying to get the protein in and chuck out the yolk, you need the yolk. You want concentration, you want good liver health, you want amazing cognitive function, you need the yolk. The yolk is good. Do not chuck out the yolk. Eggs are absolutely amazing. We're also talking about liver, beef liver, any type of liver that you're into, that other people are into. If you're not, there's liver supplements. Chicken, fish, shellfish, beef. All right. So these are the things that are absolutely high in choline. If you're a vegetarian, we were looking at some soy lecithin, quinoa, broccoli, Brussels sprouts, but they potentially don't have enough of the choline that you may need. So you potentially need supplement, especially if you've got that homozygous If you've got the homozygous, definitely supplement with some lecithin supplements, sunflower lecithin, or so forth. But it comes from a good source. Don't get your supplements from Amazon. Come on, guys, girls, you can do better than that. Get it from a trusted source that's been tested. You don't want to be putting stuff in yourself in a high dose that hasn't been tested. So the other thing is also make sure that your methylation is on point. Absolutely. Your methylation cycle needs to be on point. You need to have enough folate, B12, stress less, so you can give that SAMI for this gene to work. All right. So yes, the supplements. So I'm just going to mention some supplements here. Actually, I'm not going to talk about supplements today. Let's just stick to foods. Food is medicine. I mean, food are the answer. I gave you the golden thing. Eggs. You have this, eggs. And if you're having issues digesting it, digestive enzymes, or potentially bitters beforehand, apple cider vinegar, lemon, just sitting down, taking a breath, that's your biggest digestive enzyme. It's literally, that is your biggest digestive enzyme. All right, so we're going to talk about a research study just to wrap it up a little bit. The research study was done in 2016 in Nature. It's called insufficiency of phosphoramine N, so the PEMT gene, in risk of lean non-alcoholic liver. Although obesity is undoubtedly a major source of non-alcoholic fatty liver, the presence of lean patients with normal body mass has been recognized here, right? So this is what they're looking at, individuals who don't even look like they've got a fatty liver. They report that insufficient PEMT is at a risk of lean non-alcoholic fatty liver disease. So this gene in this research study has been linked to non-alcoholic fatty liver in individuals who are not obese. So essentially they looked at it's where it is relevant. So it mainly is prevalent 12% in Greece, 20% in India, 15% in China from the recent reports. So what they've demonstrated here is that insufficient function of that gene, the PEMT gene, is a huge risk factor for lean non-alcoholic fatty liver. Yeah. All right. Well, there you have it. I spoke about the PEMT gene, which is absolutely important for fat, liver, mental health, getting energy, cognitive health overall. If you have any questions, let me know. Happy to dive deep into them. And next solo episode, I'm going to be talking about another gene. But thank you so much for joining us on Natural Health Podcast. And remember that you are pure love, capable of living life to your fullest expression. The content and information provided here is opinion of Mihaela Raguz and is for information purposes only and does not constitute medical advice. It is not intended to provide medical advice or take the place of medical advice or any current treatment you're undertaking. Consult your own medical professionals for any medical issues that you may be having. This entire disclaimer also applies to any guests or contributors to the Natural Health Podcast. It is advised that you consult your doctor or healthcare professional in relation to any health concerns you may be having. Mihaela Raguz does not take responsibility for any health consequences which occur from a person listening, viewing, or reading this content. And in the circumstances shall the Natural Podcast, Mihaela Raguz, any guests or contributors to the Natural Podcast, or any employees, associates, or affiliates of Mihaela Raguz be responsible for damages arising from the information provided on the Natural Podcast. By listening to this podcast, you agree not to use this podcast as medical advice to treat any medical conditions in either yourself or others. Please note, if you're taking prescription, do not stop your medication or start a new protocol, including but not limited to supplements, diet, lifestyle changes without consulting a doctor or healthcare professional. If you or any person has a medical concern, you should consult with your healthcare provider or seek other professional medical advice. Never disregard professional medical advice or delay in seeking it because of something that you have read or heard on the Natural Podcast or in any linked materials. If you think you may have a medical emergency, call your doctor or emergency services immediately. Neither Mihaela Raguz nor the publisher of this content takes responsibility for the possible health consequences of any person or persons reading or listening or following the information in the educational content.